Human beings have inhabited planet Earth for hundreds of thousands of years by some estimates. Earth is all we know. But what else is out there? What is it like on Mars, Venus, and other planets? NASA is making it possible to find out. They are developing a way to get us onto these planets and explore the unknown. NASA is funding the work of researchers at the University of Vermont who are testing materials for use in thermal protection systems. These systems protect spacecraft from the extreme heat of entering an atmosphere. The current thermal protection systems utilize heavy ceramic tiles which work, but create limitations in exploring other planets. The goal of NASA's collaboration with the University of Vermont is to develop a new thermal protection system using a silicon-carbide fabric. A critical step involves predicting how the material's characteristics will function in space. The system under development uses a large, lightweight inflatable structure with a cone-like balloon attached to the front of the spacecraft. This is called a hypersonic inflatable aerodynamic decelerator, or HIAD for short. The HIAD system works like this. The flexible silicon carbide fabric is stored in the nose of a spacecraft and inflated when needed. When deployed, the HIAD is wider than the nose of the spacecraft. This deflects heat and protects the spacecraft while also using its large diameter to create air resistance and slow down the spacecraft. There's just one problem. When the soft, flexible silicon carbide material is exposed to extremely high temperatures, it will oxidize into a hard, brittle, fragile material that will break under low pressure. The University of Vermont is leading this investigation by creating simulation models and conducting experiments to determine how these materials will react under the conditions of reentry. Professor Frederick Sansoz is lead investigator on the project. His team studies at a molecular level how the mechanical and thermal properties of silicon carbide fabric materials change at high temperature.
What is very special about UVM is we do have a laboratory that is able to reproduce the same condition of reentry than in space with the exact same chemistry and the exact same temperatures.
The safety of the future missions depends on knowing the surface temperature of the material during oxidation. The UVM experiments produce only an average temperature over the area of the material. The goal is to determine more precisely the entire temperature distribution across all fibers in the woven fabric. This is where modeling and simulations come in. Computer modeling uses the lab experiment as a calibration tool. It can provide more detail about the temperature distribution, which can then be used to predict the failure rate of the silicon carbide fabric. The data UVM has obtained so far clearly suggests that there is a dramatic reduction of strength in the fabric after just 30 seconds of exposure to air. Engineers designed the silicon carbide fabric to have each silicon atom bonded to one carbon atom. Oxidation adds oxygen atoms to the mix, breaking the chemical structure of the fabric. This is currently the greatest obstacle regarding the use of the silicon carbide fabric in space. Professor Yves Dubief is co-leader on the research project. He investigates ways to develop detailed fluid dynamics computer simulations to study the rate of surface damage induced by high-temperature air or oxygen gas exposure at hypersonic speed.
Imagine that now, in between two carbon molecules, you have an oxygen molecule. This is not a stable scenario. It's not what the engineer designed the material for. That can break through intense heat or through mechanical strain and create a weakness in the heat shield material. So one of the jobs of this research is to figure out if those scenarios can happen.
Professor Ting Tan also participates in the research project in creating a brand new instrument to directly test the deformation of the material inside the plasma torch experiment.
When the materials are in outer space, their environment is different from the Earth. So that means if we have to put the pair of hands in that space and tear them apart at that time to see how strong they are.
We use the experiment to test our model and figure out how far are we from reality. What do we need to improve in our models? And then we can take those improvements and give them back to NASA so that they can make better prediction.
Researchers at the University of Vermont and NASA are not only excited to be part of one of the most audacious human endeavors, the exploration of Mars and other planets in our solar system. They are also interested in inspiring future generations for space exploration and research. Because tomorrow's astronauts are today's students, the generation that will benefit most from this research guiding future space missions.